Hey everybody. So hopefully you were able to get through page 124 and 125 explaining the process of using partial quotients. And we're going to do the try it section, problem number 5 on page 125. And before we do that, I want to explain why we're able to use partial quotients thinking about multiplication. So I put a little area model here, and you can see that it is 2 tall and it is 4 wide. And when we want to find the area of something, we multiply the length by the width. And so you can see the area here would be 8 square units. So that tells us that 4 times 2, or 2 times 4, equals 8. But you can also do the reverse. You can start with what's on the inside. Now that we know it's 8, we can say 8 divided by 2 equals 4. These are called fact families. And we could also say 8 divided by 4 equals 2. So we're basically doing that same thing, just with larger numbers. So what we're saying is we know the divisor is 3, and we already have an area of 132. And what we're going to do is we're going to find partial quotients to find the missing part of the rectangle that would give us area if we multiplied. 3 times this unknown width up here should give us 132, just like it did here. Okay, so if we didn't know this was a 4, we could say 2 times an unknown number will give us 8. Well, that unknown number has to be 4. So that's what we're doing with partial products. So the first thing we need to do is figure out a chunk of this bar that we're going to take out. So we could do 132 is kind of big, so maybe we could do 3 times 30. Let's try 3 times 30 to start. So 3 times 30. Well, 3 times 3 is 9, so 3 times 30 would be 90. Okay, that's not bad. 90 is not so far from 132. I'm going to erase this one, and we'll just keep a reminder down here that the whole thing, our dividend, is 132. Remember, our divisor is 3, and our quotient is what we're going to find by finding these partial quotients. So our first partial quotient is 90, so we used 30, because 3 times 30 is going to give us 90. But we're not done, because we started with 132. So if we want to find out what we have left, we have to use subtraction. So we'll start with our dividend, and let's subtract the part we already marked off. 2, take away 0, 2. Now 3, I wouldn't have enough, so I have to regroup this 100. Oh no, I don't have any hundreds left. But that 100 gives me 10 tens. 10 tens plus 3 tens gives me 13 tens. Take away 9 tens, give me 4 tens. And then 0, take away nothing. We don't have to. We could mark this if we want, but we don't have to. So we have 42 left. Now, I could do another partial quotient. And I know 3 times 10 is 30. So I could use 10, because 30 doesn't use up all 42. So that's going to have me use another 30. So 3 times 10 has me use up another 30. Okay, but I need to take that 30 away from what I had left from before. And that's going to leave me with 12. Now I'm getting closer to multiplication tables. What could I multiply 3 by to get 12? Oh yeah, 4. So that's going to let me use up that last 12. 3 times 4 gives me 12. So the rectangle adds up to our dividend, what we started with, and these different pieces up here add up to give us our quotient. So 30 plus 10 would give us 40, plus 4 would give us 44. Now, if we were to think about that in cookies and friends, we can make that statement, those statements we've been making, where we say we started with 132 cookies, we divided them equally amongst 3 friends, and each friend got 44 cookies. Dividend divided by divisor gives us our quotient. And what's neat is, if you look at our multiplication problems over here, if we add up all the factors that we multiplied 3 by, 30 plus 10 plus 4, that also gives us 44. Okay, good luck on problem number 6. Use the same strategy. Yeehaw. Don't laugh.